Just to know this is going to be my last video of the year, so please have a great break and I'll see you in the new year. Bye for now.
Okay, so I'm going to solve two modelling questions. I'll start with this one. Got a car moves from rest along a straight road after 2 seconds, the velocity is v meters per second. The motion is modelled by dv by dt plus alpha v equals e to the beta t. And alpha and beta are positive constants. Part A solves differential equation in terms of alpha and beta, and explain why the car will never approach rest. So, we need our integrating factor, which we call I. Alright, if you don't know why it's called I, then you need to watch the beginning of the video. It will be equal to e to the integral, be careful, of alpha t. In respect to t, yeah? Which will give us e to the alpha t. That's our integrating factor. So we get e to the alpha t plus, now that times e to the alpha will be alpha e to the alpha t times v. Now I need to times that to that, so it's e to the alpha plus beta using your index law of t. Okay, so we've got a perfect derivative, d on dt, be careful it's not in dx, it's a modelling question, don't forget, but e to the alpha tv, is that what it is? E to the alpha tv, yeah? Will be e to the alpha plus beta t. Okay, so integrating both sides, we've got e to the alpha tv, e to the alpha plus beta t, well that's 1 over alpha plus beta times e to the alpha plus beta t, plus obviously the constant of integration can go on the right hand side, it doesn't really matter. So v, I need to multiply through by e to the minus I over t, so it'll be 1 over alpha plus beta times e to the beta t, be careful because the negative will cancel out, yeah, plus ce to the minus alpha t, obviously plus the constant of integration as well. Now we're not given anything about what's happening here. All we know is it moves up from rest along the straight road after 2 seconds of velocity is v meters per second. So when t is 0, it implies that v must be 0, and so we can find basically the particular solution to the differential equation. So we get 0 equals 1 over alpha plus beta, which is fine, times e to that. Well, I'll just give those 1 over alpha plus beta. So we can essentially find alpha and beta using this. So we get c is minus 1 over alpha plus beta. Okay, so we've got that bit. Now, subbing this back in, we get v equals 1 over alpha plus beta, oh my word, this is a mess, times e to the beta t, like so, yeah, minus e to the minus alpha t. And as we know, as t will approach infinity, like so, e to the minus alpha over t will tend to 0. Yeah? Well, as we know, hang on a minute, e to the beta t will tend to infinity. So, the speed will tend to infinity, and so the car will never come to rest. So, as e to the beta t tends to infinity, v will tend to infinity, so never come to rest. Part A, Part B. That's how we solve this modelling problem.